In this media, you will learn about the working of a magnetic stabilizer. Magnetic stabilizer circuit is shown here. In this type of transformer, a magnetic shunt is there between primary and secondary limb of transformer. A capacitor is connected parallel to secondary winding. When the supply voltage is given to primary winding, it creates the primary magnetic flux. Due to this primary flux, a secondary voltage is induced in secondary winding. The capacitor causes a large reactive load current in secondary winding. Due to this current, a secondary magnetic flux circuit is created. This secondary magnetic flux passes through the magnetic shunt since it has low reluctance. This secondary portion of the magnetic path gets saturated. When the primary voltage increases, an additional magnetic flux is created in primary winding. This additional magnetic flux can't flow through the magnetic path of secondary winding since it has saturated already. Hence, the additional primary magnetic flux passes through the magnetic shunt. So, the magnetic flux created by the increasing primary voltage does not affect the secondary voltage. Now, the secondary voltage is maintained as constant to some extent, even when the primary voltage increases. An additional winding provided also helps maintain the constant output voltage. This additional winding is wound in reverse direction to primary winding. This additional winding carries the load current. It creates a magnetic flux when load is increased due to increase in primary voltage. The additional flux opposes the primary flux and reduces the secondary voltage. Thus, the output voltage is maintained at an improved constant value. Now you have learnt about the working of a magnetic stabilizer.